I'm going to go ahead and get started. So welcome everybody. This week we are going to be talking about Creo ANSYS Simulation. A very exciting, in my opinion, the most exciting simulation tool in Creo currently and going forward. This is part 3 of our simulation series. So earlier this summer, we talked about Creo Simulate. Actually, first we did Creo Simulate Live. That was a webinar that I gave in June or July. Then in August, early August, Terry talked about Creo Simulation. Now we're getting part 3, which is Creo ANSYS. So just a brief introduction of myself. I've been with PDSVISION for 5 years. My name is Sevi. I'm located in St. Louis, Missouri, formerly Cleveland. And I've done quite a bit of simulation during my time at PDSVISION, and before that, my background is mechanical engineering, and in industry, I've done some flow simulation for liquid gas separators. And very quickly about PDSVISION, we are the largest PTC global partner. We have offices in many countries, and I think this is even a little bit out of date. I know we now have an office in Spain and one in the Philippines, I believe. We mostly support PTC products, but there are some other companies that we partner with as well. Really relevant in this case is ANSYS. We are a full ANSYS partner, so not just supporting the Creo ANSYS tools, but if you need, fully equipped ANSYS workbench, we can help you there too. And lastly, just want to say that PDSVISION, we have a really great technical team. More than 65% of our staff are technical experts, which is not the norm in the CAD partner space. We really value our technical resources, and I can just speak very highly about my team. We have a really diverse and wide skill set. So with that being said, I'm going to move on to Creo ANSYS. So Creo ANSYS Simulation is a simulation tool that was added around Creo 7. And the main distinguisher between this tool and the other tools, or specifically Creo Simulate, is that this is using the ANSYS mesher and solver. So the exact same solver that industry leader ANSYS is going to be using to conduct its simulations has been brought into Creo Parametric, where that exact solver and mesher is used to analyze your CAD model. This solver is, as I said, industry leader, so it's extremely fast, it's extremely accurate, and it forms the foundation of simulation moving forward. So I want to take a little bit of time to talk about how this compares and complements Creo Simulate. In my mind, when Creo ANSYS was announced, and as it's been released and updated over the last 5 or so years, the big elephant in the room is this going to completely replace Creo Simulate? So I'm just going to jump to this next slide here. On the left side, oops, I was trying to highlight there, my fault. Gonna just exit out of the slideshow view for a second so I can highlight. But the left 2 columns here, these are the feature sets of Creo ANSYS. So this is the tool we're talking about today. It uses the fancy new ANSYS technology, the industry leader solver. And that is going to be compared to Creo Simulation, and that's over here on the right. This is a tool that's been around for decades. It's a PTC simulation tool. It's a very good piece of software, and as you can see, it has a very large set of features. So I just want to talk about the difference between these two tools because they do have, as you can see, a very similar set of features. So the question I most often get is, what's the difference? Which one's better? So to answer that question, I would say generally, if you're looking at the core fundamental technology, so the mesher, the solver, all that good stuff. First of all, it's different technology between the two. So Creo Simulate uses a P element solver, whereas Creo ANSYS uses H elements. So the core technology is a bit different between the two, and there are actually pros and cons on both sides. But I would say that in general, this is obviously a big generalization, but the Creo ANSYS solver is going to be more powerful most of the time. ANSYS continues to update their solver every couple of years. And whenever they do that, the newest version is brought into Creo. So I would say in general, the core technology with this Creo ANSYS is going to be a little bit better, but there are still pros and cons both ways. The big distinguisher, I should say, in that regard is that Creo ANSYS is going to continue to be updated going forward. Creo Simulate, as I said, it's been around for decades, and PTC has gotten to the point where they're still going to support this software. They're still going to make updates to incorporate new features, for example, multi-body design. But there are probably not going to be many big updates to this tool. Creo ANSYS, on the other hand, PTC does see this as the future, and even if they're not going to completely phase out Creo Simulate, they've basically moved all of their developers that are making new things, and they've moved them to Creo ANSYS. You can see that Creo ANSYS doesn't quite have all of the features that Creo Simulate has. There are some things, for example, joints. So joints is something that ANSYS has, but Simulate doesn't. But there are more features that Simulate has that ANSYS doesn't. You can see some of these are only marked as planned as well, so they're not actually in Creo ANSYS yet. So just to kind of summarize the difference between these two tools, Creo Simulate has been around for a very long time, and it's a mature piece of software. It has a lot of features, but it's probably not going to be getting many improvements in the future. On the other hand, Creo ANSYS is the future. It has a very good solver. It brings in the latest and greatest ANSYS technology. But it doesn't quite have the amount of features that Creo Simulate has yet. However, you can see that they're already getting very close to having, the full feature set, and they're only going to keep working on this tool going forward. So yeah, this tool is the future. It's they're adding more to it every year, and the core technology is the best you can get in the industry. So I'm really excited to get the rest of these features added in that are planned and to see where they go with it in the future. One thing that I want to cover really quick before I move on, there is one thing on this slide that's actually not in Creo 11 yet. So transient thermal here, this row that I've highlighted, that was supposed to be added in Creo 11.0. Unfortunately, it is delayed for I don't know how long. I would assume it's added in some version of Creo 11, but as of right now, this is still not in yet, unfortunately. But that's the only thing that's incorrect on this table. So this is my last slide. I want to jump into the tool and just spend as much time going through the tool, running different simulations as I can. But I just want to show, I talked a lot about how PTC is continuing to add a whole lot to this tool every single year, and it's all pretty big additions. So I just wanted to go through a quick timeline. If we go back to Creo 7, that was when this tool was introduced. Creo 9 was another big update. You had bearing load copy paste, so you can copy paste constraints or loads, for example, between different analyses. You have shell pair improvements, deformed versus undeformed shape for results, an inertia relief option, so some good stuff there. With Creo 10, you can see that the ANSYS solver, the newest version of that, was added in. I want to say they generally update their solver every 2 years, but I could be wrong on that. Additionally, with Creo 10, you get nonlinear contacts, so you can add friction between assemblies. You have nonlinear materials, which is for a long time, the reason that companies weren't going to this tool. They needed nonlinear materials and they weren't supported yet, so that's really big as well. You have combined structural and thermal studies as well. Creo 11, we get transient structural analysis. As I said, transient thermal was delayed. So we don't have that yet, but we do have conjugate heat transfer. So for example, liquids transferring heat to solids, things of that nature. All right, so with that introduction, I'm going to go ahead and jump into the tool. I'm going to start here just in normal assembly mode. This is Creo 11.1, so the newest version that we have out there. The way we access Creo ANSYS is through the Applications tab. So Simulate is the older tool I was talking about. It's still good, but ANSYS is, I would say the future. If you do not have access to this button on your ribbon, then reach out to us. You probably just, it might be a licensing problem, but you probably just didn't download Creo ANSYS when you first downloaded Creo. It's a 5 GB edition, so a lot of people don't download it unless they have the license already. So if you should have access to this and you don't, just reach out to us. It's an easy fix. So once we enter Creo ANSYS, you'll notice that the UI looks just like most of the other tools in Creo. We have a tree, so a simulation tree over here. Just like the model tree in Creo, we're going to have our simulation features organized. So all of our constraints, all of our loads, and once we run our simulation, our results are going to populate here as well. So I'm just going to take a look at the model I have here. This is an assembly. And we already have one displacement constraint. So we have this model locked in place along these cylindrical holes. And I'm going to create one more constraint here. I'm going to do a cylinder constraint, and I'm going to do that on these cylindrical holes over here. Cylinder constraint is going to allow rotation. So this is going to be like a hinge, a door hinge. And you'll notice that we have 2 loads applied as well. These are both forces that are going to be applied to this bolt. Now these are normal forces, so just a normal load. So that means it's going to be applied evenly across the entire surface. However, as of Creo 9, we do have the ability to do bearing loads. So if I was creating this for real analysis purposes rather than for demonstration purposes, I would go through and change these force loads and just copy these values in the X and Y direction. And I would just turn them into bearing loads. But for our purposes, it doesn't really matter here, just for demonstration. Now I want to show new feature here in Creo 11. We now have access to transient mode. So we can do transient structural analysis. We can have forces that vary over time. So I'm going to go ahead and go into transient mode and go into simulation setup. We'll see that we are able to create number of simulation steps and step duration. So for example, I can say I'm going to apply a force over 10 seconds. That force is going to be a whole lot of force at the beginning, not very much force at the end. We can see the deflection of our model at multiple steps over that time. So that's brand new in Creo 11, very exciting. And then if I wanted to change this force to be, a function over time, then I can just right click and change these values to a function. And you can see that I can define at each time step what these forces are going to be. All right, so I'm just going to go back to steady state. And I'm going to go into the Refine Model tab to define my contacts. So we now have full support for contact analysis in Creo ANSYS. We have nonlinear included, so I can detect contacts. And I'll just select the entire assembly here. And I'll make the tolerance 0 millimeters. So anytime assemblies are touching each other, it's going to create a contact here. And I have the ability, if I wanted to now do frictional contact. So I can do a coefficient of friction. This is a nonlinear operation. This now works fine in Creo ANSYS. I'm just going to do bonded. So basically there's no friction, but it's still going to capture the contact when these assemblies run into each other. They're just not going to slide along each other. Next, we're going to take a look at the mesh. So I'm going to jump into mesh control. One of the advantages of using this tool rather than ANSYS Workbench is that the meshing process is automated to a much larger degree. It's going to be much easier for a normal engineer to create a mesh. In ANSYS, it's a very long and complicated process. Oftentimes, in Creo, it's very, very easy, very simple. We have a mesh resolution slider here. This is going to, at a very high level, make the mesh more accurate or less accurate. So I'm just going to drag this all the way to high to make the most accurate mesh. And this is going to change these mesh size settings. I can, of course, further change these if I would like. So I'm going to change the minimum size to 2. I'm going to make that a little bit bigger so we don't get as many really tiny elements. But I'm going to change the maximum sizes of each facet or of the entire elements and make those much smaller. So the idea there is we're going to have a lot of smaller, more regularly sized elements just as a starting place, and we can go from there. And now I'll go ahead and generate the mesh. We can see our processes in Creo ANSYS are shown right down here in the bottom right. And it's already done. I can now go ahead and take a look at my mesh, and we can see exactly how my model was broken down into these little chunks. And as I said, they're all much smaller and pretty regularly sized. And lastly, if we look at our Creo info panel down here, we can see that about 69,000 mesh elements were created. And I can very quickly and easily enable or disable mesh just through my graphics toolbar here built into Creo. And the same for my simulation features. So my loads and my constraints can quickly turn those all on or off. Now I'm going to go ahead and run my simulation. So I'll press run, and again, we're going to get a progress bar down here in the bottom right. And this is the ANSYS Mesher, ANSYS Solver. So as I said, industry leader. You can be confident your results are about as good as modern engineering can get them. Of course, there's the process of refining mesh, and that's an art form. You got to learn it over time, but the technology itself is really top tier. So now I'm going to take a look at our results. We have the ability to view our results right here in the Creo window. There are a couple sets of basic results. So just von Mises stress, displacement magnitude, and displacement in each direction. These are what's going to be there by default. So I'm just going to go ahead and view von Mises stress. I can hide my simulation objects. And we'll notice that stress is going to be shown on our model. We have maximum stress here and minimum stress locations highlighted. And if we take a look at my legends, we'll see that the maximum stress across the entire model is about 85 megapascals. Now we can do a few more things with this, so I can just go ahead and play this, this animation. We can see how this thing is going to deform. Of course, this is not to scale, but if I would like to take a look at that, I can disable auto scale. And now this thing is moving to scale, but you can tell it's barely moving at all because this thing really isn't deforming too much. Now, additionally, I can do a simulation query. If I'd like to know the stress at any specific point, I can click that point. You can see that I'm given results. Additionally, I have what's called a simulation probe, and that lets me get a little bit more details in the data I want to see. So, for example, if I want to see the von Mises stress, but I want to see the maximum across the entire surface that I'm highlighting, then I can do that using this probe. You'll notice that it says not calculated. All I have to do is just right-click the model tree over here and update results. You'll see the simulation doesn't have to be rerun. It just has to, for whatever reason, it has to pull the results for the probe that I selected. So we can see the maximum on this surface right here is about 60 megapascals. Next, I'm going to define my own contour plot. So this is if we want to view results that are not in these defaults. I am actually going to do displacement magnitude, but then I'll update results. But these advanced results windows give us some more functionality as well. So I can actually enable the mesh on this contour plot if I would like. And I'll go ahead again. What we're seeing now is displacement. So this is our point of maximum displacement and minimum displacement. And we can see that our maximum is about 0.0267 millimeters. Okay. So that's what I would say is the basics of a structural analysis. I'm going to go in a couple other directions here. First thing I'm going to do is I'm going to do some local mesh refinement. So we noticed that the maximum stress were on these elements here. So I'm just going to further refine the mesh, make the mesh a little bit more accurate in these areas, and we can see how it changes our results. So I'll go back to the Refine Model tab. I'll go back into Mesh Control. But instead of a global mesh size, I'm going to do a local mesh refinement. And I'm just going to do this on these surfaces right here. We'll make that size, local mesh size, 1 millimeter. I'll go ahead and generate my mesh, and I'll display it. And we'll notice when I zoom in, we'll now see that the mesh elements on these that touch these surfaces are much, much smaller than the elements around it. We now have a total of 95,000 elements. So in theory, we're going to be getting much better results in these areas. So now with that done, I'm going to go ahead and rerun this, and we'll see how our results change. And just want to point out, the mesher is extremely fast. It created those 90 whatever thousand elements just 5 seconds or whatever it took. I can't speak highly enough about, the core technology behind this tool. Of course, this is going to take a little bit longer because we refine the mesh a little bit more. It's always in simulation a balance between, simulation runtime for more accurate results. And it's finding that sweet spot where your results are as accurate as you need them to be. And your simulations don't take, weeks to run. I would say that's easier and easier every time they release a new version of the solver because it gets a little bit stronger. But, that's the core of what simulation is. It's always going to be in that balance of how accurate do I need my results to be? How much time do I realistically have to get those results? And in the case of this demonstration, I need this to run relatively fast. So, these results could be more accurate if I was in a real design scenario, real analysis scenario. So we'll see with that update. So I'll just go into basic results again and look at von Mises stress. My maximum is now 97 instead of about 95, what it was before. And additionally, the stress over here, which was closer to 60, is now showing a mass stress along the surface of 88. So what we can conclude from that is that in these areas of high stress, we really did need that additional mesh refinement. It changed our results. Over here, not as much, but over here quite significantly by further refining that mesh. Okay. Now I'm going to show one of the new features that came with Creo 10. This is going to be a combined thermal structural analysis. So I'm going to go ahead and check include thermal, and we'll see that we have thermal boundary conditions and thermal loads that we can now add. So I'm going to apply a convection condition to our entire model, to every surface on our model, I should say. So this is basically simulating the air cooling our model off. And our ambient temperature, this is our room temperature. We'll assume this is operating somewhere hot. We'll say this is 30 degrees Celsius. And now we're going to add in a heat load. I'm going to add in a heat load right over here. And change this to watts. We'll make this 3 watts. So I just want to point out, since I changed some things with my simulation, I added this heat aspect to it. We'll see that this yellow flag is displaying by this simulation. This is basically saying our results are not up to date anymore. We need to rerun this thing in order to get accurate results. So that's all the setup I wanted to do here. I added my heat load and my convection coefficient. So I'll go ahead and rerun this. Combined structural thermal is interesting because essentially when you add thermal loads, this is going to change the size of your model. When metals are exposed to heat, they're going to expand, they're going to get larger, and this can actually cause stresses. So these combined cases are tricky because as you add heat, it's going to change the structural results. That's going to change the shape of your model. So it's really great that this is now built in. We can understand how our model reacts in real world conditions that include heat and structural forces. Now, while this runs, I'm just going to point our attention to the model tree over here. I'm going to minimize this structural analysis. And we'll see that we actually do have a modal analysis over here as well that I'm going to jump to in just a second. Looks like our structural completed, so I will jump back here and we can take a look at our results. So first I'll go to displacement magnitude, and we'll see that the max displacement actually changed a whole lot with that heat load added. It was something like 0.02 something millimeters. Now we'll notice that the max displacement is actually 0.07 millimeters, and that's due to the heat load that we added in. If we want to visualize this a little bit differently, I'm going to create a new contour plot, but this time I'm going to show temperature. And I got to update my results real quick, and then I'll go ahead and display that. And we can see that heat load added is increasing the temperature of this metal part by about 2.5 degrees Celsius compared to the baseline of 30 Celsius on the rest. Okay, so with that, I'm going to jump into the modal analysis that I mentioned a bit ago. So we'll notice that this modal analysis, it all appears in the same tree, very easy to jump back and forth. I have one displacement constraint here. What I'm going to do is I'm going to find that cylinder constraint from my previous analysis, and I'm just going to copy and paste it. We have the ability to copy and paste, including multiple items at a time between our analyses, which is a huge time saver. You can see it's really easy. Now our cylinder is going to appear in our modal analysis. Now I'm going to, again, do a contact detection. So I'm going to go ahead and detect contacts between my assemblies or my components. And again, I'll treat these as bonded, but we do have the ability as of Creo 10 to do friction if we would like as well. And again, I'm going to put in my same mesh controls that I did before as well, and create a similar mesh to what we had in the last example. And if we look at our mesh, we'll see it's the same 69,000 elements that we had originally. Now, before I run this, I'm actually going to define my results. So I'm going to create one that shows mode 1 and another plot that shows mode 2. So my first two modes of vibration. And I'm going to change my simulation setup to only calculate 4 modes. And then I will go ahead and run. So modal analysis, of course, is used to find the natural frequencies of our model. So how this model is going to vibrate or resonate rather. It'll tell you which wavelengths this is going to resonate at. So the hertz, the frequency of the vibrations, I should say, rather than wavelength, the frequency. It's going to tell you that information, and it's going to tell you how your model is actually going to vibrate, how it's going to move in those situations. So this is now completed. I can go ahead and enable my first mode. And I can just go ahead and play this as well. And we'll see the cylinder constraint. This thing can rotate and slide along this axis. We can see that this thing is going to move back and forth in that direction. I'm going to define a simulation probe here as well to show a frequency table. And this is going to show the 4 modes that we calculated. So the first is going to be at 163 hertz, then 647, etc. Now I can switch to my my mode number 2, and we can see that this one is going to move in a different direction, and this is going to happen at 647 hertz. I can also change the speed that this animation goes if I would like. So I just drag that to the fastest, and now I'll drag it over to the slowest. All right. I think the last thing I want to do is I'm just going to make a couple design changes. This is something that you would usually do after getting your results. You make some changes to your design so that those results are a little bit closer to what you want to see. So what I'm going to do is I'm going to just quickly change some dimensions. I'm going to make this, rather than 2.5, this sheet metal piece, I'm going to make this 3 units thick. And additionally, I'm going to change some dimensions on here as well. So I'm going to change this 28 length to 30. And regenerate. Now I'm going to go to the other bracket as well and make some similar. So again, I'm going to change the length, just make it a little bit longer from 50 to 51.5. And I'm going to change the thickness of this entire sheet metal piece from 2.5 to 3. And regenerate. Now I'll jump back into Creo ANSYS. And we can rerun all of these or any of these, or and see how they react. But I'm just going to go back to my structural because we remember the numbers. The maximum stress was about 97 or so. When I ran this the first time. So I'm going to go ahead and rerun this. And we'll actually use this 88 as our metric for comparison. So the von Mises stress over here was about 88. Before the design changes, we'll see how it changes. After this most recent run. And we're done. So we're going to go ahead and take a look at these results. So in the metric we were looking at, the maximum stress on this bracket decreased from 88 megapascals down to 56. And our maximum decreased from about 97 down to 66 over on this side of our model. If we take a look at temperature, max temperature is about what it was before, pretty much unchanged. But due to the thicker size of this bracket, I'm sure if we measured the temperature on the outside, which I wish I did before I ran it, but that should be significant. So that is all I have. That is all I wanted to show today. So just to recap, we covered most of the features in Creo ANSYS currently. That includes some new features such as combined thermal structural and transient mode for structural, where we were able to create loads as a function of time. Unfortunately, we don't have transient thermal yet. That's okay. That should be coming soon. We have support for nonlinear contacts. So contacts now support friction. We have nonlinear materials. We have bearing loads. We have modal analysis, et cetera, et cetera. So to summarize, this tool has, the best technology that's out there. It's the future of simulation in Creo. The feature set is not quite up to Creo Simulate yet, but it is getting there, and every single year, every single Creo update, they add more and more. So really excited about this tool. So I'm going to put some email addresses up on the board. My name was Sevi, and I put my email up here if you have technical questions. And I also put our sales team's email up here as well. So if you're interested in trying this software out or implementing it for your team, feel free to reach out to me or reach out to sales. Now I'm going to open it up to questions. GoToWebinar supports a question and answer functionality. So feel free to submit your questions into GoToWebinar and I will see them. Otherwise, you can always submit questions to my email, but I will give everybody just a minute or two to get their questions in, because I always think it's better to just speak to them. So I have one question. Do you need a separate license for ANSYS Simulation, or can you use Premium Plus? So I can answer your question partly, but I might have to follow up for part of it. So when you say Premium Plus, I'm not completely up to speed on what you mean by that, but I'm assuming that that's the name of one of the Creo tiers of licenses. So for example, Creo Design Essentials is the tier 1. So for your specific license, the Creo Premium Plus, I'm not exactly sure which tier that correlates with and what is included. So I will have to follow up with you if you specifically with your license have access to this. But what I can say is that Creo Design Essentials, so this is the very base level of Creo, just the tier 1 license. This is going to include Simulation Elite. So this is going to include a good amount of this Creo Simulate. For most Creo license packages, they are not going to include Creo ANSYS. So most of the time, it is going to be an add-on. As I said, I don't know about your specific package. I'll have to look into it. But if I had to guess, I would assume that this is, you know, extra. It's not included. But I can definitely check on that for you, and I'll follow up with email. All right, that appears to be the only questions we got today. Oh, never mind. Sorry, missed one. My fault. There we go. Is there an ability to refine the color scale for results in Creo ANSYS? I know this can be done in Creo Simulate. Yes. So the question, if I go ahead and just look at my results here. Oops. Just a second. I'm not sure what's going on here. I'm gonna rerun this. I think I need to rerun because I made some changes. So sorry, just a second. But the answer is yes, we can change that. We can change the scale or the legend of the contour plot. And I will show you how in just 1 second. Oh, I know why. It's because I disabled include thermal and enabled transient mode, I guess, for whatever reason. So that's why my results weren't updated. So if we look at these options down below, so first of all, this toggles between like distinct colors and just a continuous tone. And this option, it's toggle from automatic or user editable top and bottom values. So this is what we are interested in. So I can change the bottom value. Let's say I'm only interested in values above 0.02. I can change this to 0.02. And just see, you know, the range in here. Now, in terms of the middle values, you might actually not be able to change those. Let me see if I can figure that out. I'm actually not sure you can change the ones in between, but I will look into that. And if there is a way, I will let you know. But yeah, at the very least, we can do we can define a range here of our choosing, and then Creo will apply these colors over the range that we choose. Question was, another question, I may have missed this, but is there a plan to add dynamic loading to Creo ANSYS Advanced? So depends what you mean by that. So dynamic analysis, going back to my slideshow, dynamic analysis, so fully fledged dynamic analysis is not yet marked as planned, but I would assume that it is planned for some amount of time. It's just not on the immediate radar. If you mean, however, if you mean just varying your structural loads over time as a function, that we can do. So that's actually was added, transient structural was added this year in Creo 11. You might have missed that at the start, or you might just be asking about full dynamic analysis. But either way, I'll just show it again really quick. We can do transient mode, and then we can vary these loads by function. So I can do new function, excuse me, and add various values here for each timestamp. But in terms of fully fledged dynamic analysis, that's probably going to be a couple more years, to be honest. And I don't know specific plans. So I say probably a couple more years. It could be, could be next year, could be never. I don't have any info about it either way. But I would assume that they're at least working on it. Okay, I think that is all the questions we got. I'm gonna go ahead and leave my email up here. This video is going to be recorded, so a re-recording of our webinar is going to be available on our website within a couple days. Besides that, you have my email. Feel free to reach out if you have any questions about this whatsoever. So thank you everybody so much. My name has been Sevi with PDSVISION, and I hope you have a great second half of your week. Thanks again.